For decades, our origin story seemed simple. Humans evolved from something that looked and acted a lot like a chimpanzee. Knuckle walking, tree swinging, and aggressive. Then, step by step, we stood up, walked across the savannah, and became us. But that version of history is wrong, because buried deep in the ancient soils of Ethiopia, researchers began uncovering something utterly bizarre. A species that didn't walk like chimps, didn't live in open grasslands, and didn't behave like the brutish ancestors we imagined. This species, Ardipithecus, lived over 4 million years ago in a dense wooded environment. Their bodies were an evolutionary contradiction. A grasping toe for climbing trees, but hips and feet adapted to walking upright. Hands not suited for knuckle walking. Small, blunt canines that hinted at a social world different from what we see in chimpanzees today. They didn't look like us, but they didn't look like chimps either. They were something else, something in between. And their discovery caused scientists to reimagine what our earliest ancestors might have looked like. This is the story of Ardipithecus, an ancient, uncanny human relative that looks utterly bizarre. An awkward, tree-walking biped that helped us rewrite the opening chapter of the human story. Let's rewind back to 1992. A team of scientists is working in the Middle Awash region of Ethiopia, a stretch of ancient, fossil-rich land that's become one of our most important places in the world of studying ancient humans. They are looking through layers of sediment that are millions of years old, when they stumble across some unusual teeth. They clearly belong to a species of ape, but they are distinct. More bones turn up. They find over 100 fragmented fossils belonging to one individual. But the bones are fragile, so fragile that they crumble if touched wrong. Excavation and reconstruction took years, but eventually they pieced together a truly strange hominid. It is a female, roughly 4 feet tall and around 110 pounds. She lived 4.4 million years ago. Her body is ape-like, her skull small and uncanny. They named her Ardi, short for Ardipithecus ramidus. At first, you might think, okay, just another ancient skeleton. But Ardipithecus wasn't just another fossil find, it was a revelation. From the very beginning, it was clear that this species was unlike anything we had seen before. Very different from Lucy, the famous Australopithecus afarensis who lived around 3.2 million years ago. And as more fossils were uncovered, over 35 individuals so far, it became undeniable. Ardipithecus challenged much of what we thought we knew about our origins. First, the way the species moved. Ardipithecus stood upright and was bipedal. Bipedalism is one of the defining features of being human. But they didn't walk the way we do. Their pelvis was broad and short, like a human's, helping them stabilize their torso when upright. But their feet were totally different. They had an opposable big toe, like a chimp, perfect for grasping branches. But the rest of the foot was adapted to upright walking. Ardipithecus could walk upright and bipedally, but also climb like an ape. And that changes the timeline for when we think bipedalism may have evolved. We used to think it only happened once humans started to move around open grasslands. But Ardipithecus lived in a forest, not a dry savanna full of big cats and open plains, but a closed canopy woodland. This challenged the savanna hypothesis, the idea that humans started walking upright to see over tall grass or carry tools across open space. Ardi shows us bipedalism may have started in the trees, as a way to move between branches, or as a more efficient way to stand and reach food. We now think that bipedalism developed over a long period of time in a variety of environments. A detailed study of fossil pollen and animal remains show that Ardi lived in a woodland environment alongside monkeys, antelope, and even elephants. It was a complex and dynamic environment, and perhaps being bipedal and arboreal would have been a major advantage. Ardipithecus seems to have had a mixed omnivorous diet which mainly consisted of soft, forest-based foods. Unlike Paranthropus with its mighty jaws, Ardipithecus has smaller molars and thinner enamel, which suggests they primarily ate fruit, leaves, seeds, and some roots and tubers. The absence of large, sharp canines also supported a diet that didn't require tearing meat or competing aggressively for mates or for food. They probably gathered food both in the trees and on the ground, reflecting their unique combination of upright walking and climbing. This flexible diet reveals a key transitional stage in hominin evolution, before the emergence of tougher, more specialized diets seen in later species like Australopithecus. But Ardipithecus gets even more interesting when we look at their hands. Despite being only 3 million years distant from our last common ancestor with chimpanzees, Artie's hands weren't built for knuckle walking. They lacked the locking wrist joints that chimps and gorillas have. This tells us something big. Knuckle walking likely evolved after the human and chimp split. That is, we didn't evolve from a chimp-like knuckle walker. Chimps evolved into knuckle walkers after our evolutionary paths diverged. This reshaped how we thought about our last common ancestor. For decades, people assumed that the last common ancestor between humans and chimps looked, well, like a chimp. I think that much of the public still thinks that we literally evolved from chimpanzees, if they think we evolved at all. But this is not true. Like all animals, chimpanzees are on their own evolutionary path, and they have become their own thing. Our last common ancestor with chimpanzees may have looked somewhat like Ardipithecus, as we will mention later. Another fascinating aspect about her remains were her teeth. In primates, canine teeth aren't just for chewing. They're social and physical weapons. Especially in species like chimpanzees, males use their long, sharp canines to fight, intimidate, and establish dominance. In many species, the bigger the canines, the more violent and hierarchical the society. By looking at chimpanzees, many imagine that our ancestors would have been similarly violent and brutal. But Artie's canines were small and blunt, not designed for slashing or stabbing. And there's no honing complex. No evidence that her upper and lower canines were sharpening against each other as they do in chimps. This suggests that Artie's species may have had lower levels of male-to-male aggression. They may have spent less time fighting over mates and more time cooperating. This may even be a sign of pair bonding, not romantic love in the human sense, but something more stable than the chaotic dominant systems we see in chimps. So Ardipithecus wasn't just physically different. They might have behaved differently. And if that's true, then the roots of human social behavior, things like empathy, cooperation, and reduced aggression, might go back even further than we once thought. This is very important and has major consequences for our understanding of our own evolution. Chimpanzees are known for their aggressive behavior, both within and between groups. They engage in coordinated attacks against rival bands and have been observed killing members of their own group in disputes over dominance or resources. Bonobos, in contrast, display lower levels of physical aggression and tend to resolve conflicts through social bonding behaviors like grooming and sexual interaction. However, while they're generally more peaceful, isolated incidents of serious aggression have been recorded, though there are no confirmed cases of bonobos killing each other in the wild. The small, blunt canines of Ardipithecus suggest that early hominins may have experienced lower levels of male-to-male competition compared to modern chimpanzees. This could point towards more cooperative or less overtly aggressive social structures than we might expect, though exactly how they behaved remains a matter of ongoing research. Another interesting feature of Ardipithecus was its brain. It was quite small at only between 300 to 350 cubic centimeters in volume. This is slightly smaller than a bonobo or a female chimpanzee brain, and quite a bit smaller than an Australopithecine brain. It is just so strange that these guys were walking around upright and may have seemingly looked human at a glance, yet had a brain smaller than a chimpanzee. Ardipithecus ramidus was a truly bizarre hominin when compared to ourselves, but in the context of its time, it wasn't alone. Before ramidus, there was another Ardipithecus species, Ardipithecus cadaba. It was even older at around 5.8 million years old. These two species form a bridge between the apes of the Miocene era like Sahelanthropus or Auroran, and the more well-known Australopithecines like Lucy. They sit right at the base of the hominin family tree, just after the split with our last common ancestor with chimpanzees, which likely occurred around 6 to 7 million years ago. And that's important because Artie gives us the earliest fairly complete snapshot of what our ancestors were like just after that split. We can see that bipedalism was awkwardly evolving, canines were reduced, and cooperation increased, perhaps laying down the groundwork for Australopithecines. The Australopithecines would spread over much of Africa, and they are the direct ancestors of our genus. Meaning it is possible that Ardipithecus is one of our earliest direct ancestors, though this is not certain and could change drastically with future findings. So what do we take away from this? First, chimpanzees aren't living fossils. They've been evolving too. In some ways, they've changed more than we have since our paths split. So comparing ourselves to chimp might actually give us the wrong idea about what our ancestors were once like. Second, those traits we think of as humans, such as walking upright, social cooperation, reduced aggression, go back way further than we once thought. and Artie had the beginnings of all of them. Third, think of what else might lie buried in the Sahara or the caves of South Africa that could change our ideas about what it means to be human. Think about what had to happen for Artie to be found. Her bones had to survive 4.4 million years. They had to be buried, fossilized, and preserved just right. Then they had to be found, identified, and reconstructed over years of painstaking work. And even then, the interpretation was debated. Some scientists didn't believe that Artie walked upright at all. What Artie tells us is clear. The human story didn't start with chimp-like ancestors deciding to start walking upright on the savannah. Our early evolution is more complex and nuanced than we once imagined. It wasn't a straight line, it was a mosaic filled with experiments in locomotion, social behavior, and anatomy. And every fossil like Artie is a reminder, the story of us is still being written, piece by ancient piece. And Artie is one of the earliest chapters in our story, the greatest story ever told. Thanks for sticking around to learn about one of our strangest human ancestors. It's really bizarre to think, Ardipithecus and some of these other species were running around for over 1 million years, just a planet full of apes, literally like Planet of the Apes. Anyways, yeah, thanks for watching. Like, comment, subscribe, hit that bell icon so you never miss out on a video. And also remember to check out northo2.com. It's my website, and I've been selling these Lion Man statues on there. I'm going to add human skulls and a bunch of other cool stuff soon. But as of now, I just have my merch and then those Lion Man statues, so go check it out. This has been your host, Northo2, and I'll see you in the next one. Arrivederci.